Imagine you are standing in a quiet observatory dome on a mountaintop in Padua, Italy, late on a clear winter night in January 1610. The only sounds are the gentle creak of wood as the dome rotates slowly, following the sky's patient movement, and the soft scratch of quill on paper as Galileo Galilei records what he sees through his brass telescope. Cold air flows through the open dome slit, carrying the distant scent of pine trees far below in the valley, mixing with the smell of candle wax and old parchment. Through the telescope, barely more than two curved lenses mounted in a leather-wrapped tube, Jupiter hangs steady and bright against the black velvet of space, and around it, impossibly, four tiny points of light that weren't in these positions last week. Moons. Other worlds, orbiting another world. The quill scratches steadily as Galileo makes careful sketches of their positions, measurements, patient documentation of a discovery that changes everything about how humanity understands the heavens. Outside, the universe turns slowly, stars wheeling overhead in their ancient patterns, the same motion they've traced for billions of years. Inside this small dome, one man watches planets he can never visit, worlds that will fascinate humanity for centuries to come. The quiet work of understanding our solar system continues, as it has for generations, as it will for generations to come. Good evening. Welcome back. If you're new here, welcome. Tonight is a good night to rest. Find a comfortable position wherever you are. Dim the lights if you haven't already, or turn them off completely. Adjust your pillow until it feels just right. Maybe turn on a fan for soft background noise, or simply let the silence settle around you. Let your breathing slow naturally, becoming deeper, more relaxed. You're safe here. There's nothing urgent, nothing requiring your attention or energy. Just the slow unfurling of cosmic history, told in a way that asks nothing of you except to listen, or to drift away, whichever feels right in this moment. Tonight we'll slowly explore our solar system from its birth in a cloud of dust and gas 4.6 billion years ago through the patient formation of planets to the detailed characteristics of each world circling our sun. We'll visit rocky planets close to the warmth of our star, gas giants in the outer cold, icy worlds at the edge of the sun's influence. It's a long journey through space and time, told slowly, with many details and atmospheric moments from different eras of discovery. Perfect for drifting off to sleep. If this story helps you rest, feel free to like or subscribe. I'm always curious where you're listening from, so if you feel like it, comment your city and what time it is there. But no pressure at all, just relax and let the story carry you where it will. Now let us return to that moment in Galileo's observatory. But first, to understand the significance of those four moons orbiting Jupiter, to appreciate what it meant for humanity to realize other worlds exist beyond Earth, we must step back much further in time, back before Earth existed, before the sun ignited, back to when our entire solar system was nothing more than a cold, dark cloud floating in the spiral arm of a young galaxy. Imagine you are drifting in the Milky Way galaxy 4.6 billion years ago, in a region of space that will one day be called the Orion Arm. There are no planets here yet, no sun, no Earth spinning with its blue oceans and white clouds. There is only a vast cloud of gas and dust, a nebula spanning billions of kilometers, so diffuse that if you could reach out and grasp a handful of this material, you would close your fingers on essentially nothing, just a few atoms of hydrogen and helium, perhaps a grain of dust no larger than the particles that float in sunlight streaming through a window. Though there is no sunlight here yet, only the faint glow of distant stars. Other suns in other parts of the galaxy, their light taking years to reach this quiet, cold place. The cloud is mostly hydrogen, the simplest and most abundant element in the universe, each atom being just one proton and one electron, the building block of stars and planets, and eventually, impossibly, people who will one day look back and try to understand this moment. Mixed with the hydrogen is helium, formed in the Big Bang 9 billion years earlier, and trace amounts of heavier elements, carbon, oxygen, iron, silicon, these being the ash of previous generations of stars that lived and died before our sun was born, their outer layers blown into space by stellar winds or explosions, enriching the interstellar medium with the raw materials needed to build rocky planets, needed eventually to build the biochemistry of life itself, though life is unimaginably far in the future from this cold beginning. The cloud rotates slowly, almost imperceptibly, having inherited some angular momentum from the turbulent motions of the galaxy, from the spiral arms sweeping around the galactic center, from the supernova shock waves that compress interstellar gas, from 100 different influences that set this cloud spinning at a rate so slow that a full rotation takes millions of years. But spin it does, and this rotation will shape everything that follows, will determine that planets orbit in the same direction, will explain why they all circle the sun in nearly the same plane. Billions of years from now, when Kepler puzzles over orbital mechanics and Newton works out the mathematics of gravity, this ancient rotation being the reason for patterns that will seem so elegant, so ordained, so inevitable. The temperature here is perhaps 10 Kelvin, just 10 degrees above absolute zero. Cold, almost beyond imagining, though in the vacuum of space temperature is a strange concept, being really just the average kinetic energy of the sparse particles drifting through this region, most of space being so empty that temperature becomes almost meaningless, heat having nothing to conduct through, radiation being the only way energy moves, photons crawling across the light years at their unchanging cosmic speed limit. Something disturbs the cloud. Perhaps a nearby star explodes as a supernova, the shock wave rippling outward, compressing the nebula. Perhaps the cloud simply reaches a critical density through random fluctuations, through the patient drift of gas over millions of years. Enough mass collecting in one region that gravity begins to matter, begins to pull material inward, the pull being infinitesimal at first, barely winning against the random thermal motions of atoms. But gravity is patient, relentless, always attractive, never repulsive, and over time, over vast amounts of time measured in millions of years, gravity wins. The cloud begins to collapse. Millions of years, as material falls inward, the cloud rotates faster. Conservation of angular momentum being an iron law of physics. Like an ice skater pulling in her arms to spin faster, the cloud pulling inward and spinning faster. The rotation preventing collapse in the plane, perpendicular to the spin axis, material falling inward but also spreading out into a disk. The cloud flattening like pizza dough being spun. Though the process takes millions of years rather than seconds, the same physics operating on vastly different scales, the same laws that govern a spinning figure skater also governing a collapsing stellar nebula. The unity of physics being one of the universe's most beautiful features, the same rules everywhere, always. The disk grows denser at its centre, where most of the mass accumulates, the region that will become the sun, while the outer disk, the region that will become planets, remains much thinner, most of the nebula's mass falling to the centre, 99.8% eventually gathering there, leaving only 0.2% in the disk to build everything else. All 8 planets, all the moons, all the asteroids and comets, all being constructed from less than 1% of the original cloud's mass, the sun being the dominant gravitational feature of the solar system by far, being what holds everything else in orbit, being the reason we speak of the solar system, from Sol the Latin name for the sun. The centre grows warmer as material falls inward, gravity converting potential energy into kinetic energy, into heat. The collisions of infalling gas heating the proto-sun, the temperature rising from 10 Kelvin to hundreds, then thousands, then millions of degrees, the process being steady, patient, the gravitational energy available being enormous, the mass of the proto-sun being so large that even though each atom contributes only a tiny amount of energy as it falls, the collective heat becomes substantial, becomes enough to make the centre glow, first in infrared, invisible to human eyes, then in visible light. A dull red glow deep in the swirling disk, hidden by the surrounding cloud of dust and gas, the proto-sun beginning to shine even before fusion starts, even before it becomes a true star. The warmth coming from gravity alone, from the weight of its own mass crushing inward. In the disk surrounding the proto-sun, dust particles drift and collide, stick together through van der Waals forces and electrostatic attraction, the same forces that make dust bunnies accumulate under furniture, except here the particles are drifting at meters per second, meeting gently, adhering, slowly growing from microscopic grains into larger aggregates, from sand-sized to pebble-sized to boulder-sized. The growth being exponential once started, larger objects having more surface area to intercept smaller ones, having more gravity to attract nearby material. The rich getting richer in this cosmic economy. The process of accretion being one of the fundamental mechanisms by which the universe builds structure, how planets form from dust, how galaxies form from clouds of dark matter, how everything complex emerges from the simple gravitational collapse of diffuse material. Millions of years pass, the timescale being almost incomprehensible to human minds accustomed to measuring change in years or decades. But to the universe this is quick, this is active construction, most of cosmic time being spent in stable configurations, stars burning steadily for billions of years, planets orbiting unchanged for eons. But this phase, this period of formation, being dynamic, being when the major structures emerge, when the architecture of the solar system is determined, the positions and sizes of planets being decided, the fates of worlds being written in the patient accumulation of dust and gas and ice. The boulders become planetesimals, objects kilometers in size, their gravity now strong enough to affect their neighbours, to pull in nearby material actively rather than just passively collecting what they happen to encounter. The growth accelerating, runaway accretion beginning, the largest objects in each region of the disk dominating their neighbourhoods, growing at the expense of smaller competitors, clearing out their orbital zones through collisions and gravitational perturbations. The process being competitive, being almost Darwinian, though the selection is purely physical, purely mechanical, no life involved, just gravity and momentum and random chance determining which objects grow large enough to survive, which remain small and get consumed by their larger siblings. Near the proto-sun, within a few astronomical units, one astronomical unit being the distance from the Sun to Earth, roughly 150 million kilometres, a useful unit for measuring the solar system's vast scale. The disk is warm, too warm for water ice to persist, water existing only as vapour unable to condense onto grains, only rock and metal being solid, only these refractory materials being available to build planets. This inner region being where the rocky planets will form, where Mercury, Venus, Earth and Mars will eventually coalesce from the warm dust, their compositions being determined by this temperature gradient, by their distance from the heat of the forming sun. Farther out, beyond about 5 astronomical units, beyond what astronomers call the snow line or frost line, temperatures drop below 150 Kelvin, cold enough for water ice to condense, for water vapour to freeze onto dust grains. The availability of water ice making an enormous difference because water is so abundant, being one of the most common molecules in the universe after molecular hydrogen. The addition of ice to the solid material available for planet building roughly tripling the mass of solids in the outer disk compared to inner disk. This being why the outer planets grow so much larger, why Jupiter and Saturn become gas giants while Mercury remains tiny. The snow line being one of the most important boundaries in planetary formation, dividing the warm, rocky inner system from the cold, icy outer system. The division being visible even now in the compositions of planets. The inner four being dense, rocky worlds, the outer four being lower density ice and gas giants. Remember that rotating cloud we started with? Now, millions of years into collapse, it has transformed into a dense, hot protostar at the centre, surrounded by a flat, rotating disk of dust and gas, the disk stretching billions of kilometres, glowing faintly in infrared from the heat of collisions, most of the radiation being invisible to human eyes, though if we could see it from outside, it would look like a dark disk with a bright spot at the centre, similar to the protoplanetary disks that modern telescopes observe around young stars in nearby star-forming regions like the Orion Nebula. The same process happening in thousands of systems throughout the galaxy, planet formation being a common outcome of star formation. Our solar system being typical rather than special, the universe making planetary systems routinely, the conditions for worlds being abundant. At the centre of this disk, in the proto-sun, the temperature continues rising as more mass falls inward, the core now reaching several million Kelvin, the hydrogen nuclei moving so fast that they occasionally overcome the electrostatic repulsion between their positive charges, coming close enough for the strong nuclear force to bind them. 4 hydrogen nuclei fusing into one helium nucleus. The process releasing energy. The energy being what makes stars shine, the energy being what will power the sun for 10 billion years, though the fusion doesn't start all at once, doesn't happen in a dramatic moment, instead beginning gradually as the temperature climbs, the first few fusion reactions being rare, isolated events, but as the core temperature continues rising toward 10 million Kelvin, fusion becomes more frequent, releases more energy, the energy creating pressure that pushes outward, and eventually, roughly 50 million years after the cloud first began to collapse, the outward pressure from fusion exactly balances the inward pull of gravity. The proto-sun reaching equilibrium, becoming a main sequence star, settling into a stable configuration that will last billions of years. The patient burning of hydrogen into helium providing steady heat and light to the disk of material still swirling around it. The star being born not with a bang but with a gentle brightening, a steady glow that will barely change for eons. The ignition of fusion changes the disk dramatically. The sun's radiation heats the inner disk, the solar wind, a stream of charged particles flowing outward from the sun's corona, begins to blow, the wind being powerful enough to push on gas, to clear the remaining hydrogen and helium from the inner solar system, the light elements being blown outward, leaving behind only rock and metal close to the sun. The inner disk being stripped of gas before large, solid cores can form and capture atmospheres, this being why Mercury, Venus, Earth and Mars remain relatively small, being made only of the heavy elements, while Jupiter and Saturn, forming farther out where the solar wind is weaker, manage to gather massive atmospheres of hydrogen and helium, becoming gas giants, their cores having formed quickly enough, becoming massive enough that their gravity could hold onto hydrogen before the solar wind swept it away. The timing being crucial, a race between planetary formation and atmospheric loss, the outcome determining which worlds become Earth-like and which become Jupiter-like. You now watch the disk perhaps 10 million years after the Sun's ignition, the system being what astronomers would call a young solar system. The planets not yet formed, but the planetesimals being numerous, hundreds of Mars-sized protoplanets orbiting in the disk, their paths crossing occasionally, their interactions being gravitational, orbits shifting, objects colliding or flinging each other to different locations, the solar system being chaotic, violent, in a slow-motion way, the energetic impacts reshaping surfaces, melting rock, vaporizing material, each collision being a step in planet formation, material aggregating or fragmenting, depending on the impact speed, depending on the angle, the whole disk being a dynamic, evolving structure, not yet settled into stable configuration. In the inner solar system, several dozen moon-sized to Mars-sized bodies orbit chaotically, their paths crossing, collisions inevitable. One of these objects will eventually become Mercury, several others will merge to form Venus, perhaps 4 or 5 will combine to create Earth, and several more will build Mars. But right now, in this early chaotic phase, the final configuration is undetermined, the outcomes depending on countless small accidents, which objects happen to collide, at what velocities, at what angles, the specific history of Earth depending on events that could have gone differently, the Moon owing its existence to one particular giant impact that might not have happened, the contingency of planetary formation being somewhat unnerving, our world existing partly due to chance, though the general outcome, rocky planets in inner system, gas giants in outer system, being fairly predictable given the initial conditions, the details varying, but the broad pattern being repeatable. Beyond the snowline in the region that will become the outer solar system. The process is similar but faster, the availability of ice allowing planetesimals to grow larger more quickly, the larger solid cores forming in just a few million years, and once a core reaches about 10 Earth masses, its gravity becomes strong enough to capture hydrogen and helium from the surrounding nebula, the gas falling onto the core being gravitationally bound, the planet growing rapidly as it accretes a massive atmosphere. Jupiter's core reaching this critical mass first, perhaps 3 or 4 million years after the Sun ignited, the core then capturing enough gas to become 318 times Earth's mass, becoming the dominant planet, its gravity affecting everything else in the solar system, stirring the asteroid belt, ejecting objects to distant orbits. Jupiter being the second most important gravitational feature of the solar system after the Sun itself, its presence shaping orbits, affecting the formation of other planets, possibly preventing a planet from forming in the asteroid belt region through its gravitational interference. Saturn forms similarly, its core reaching critical mass perhaps a million years after Jupiter, capturing enough gas to become 95 Earth masses, being the second largest planet, similar in composition to Jupiter but less massive, the two gas giants dominating the outer solar system, their gravity being what controls the architecture beyond Mars, their masses being so large that they affect each other's orbits, their positions having shifted over the solar system's history, possibly migrating inward then outward in the first 100 million years. The Nice model suggesting this migration explains several features of the current solar system, including the late heavy bombardment that we'll discuss soon, though the details remain debated, planetary migration being difficult to observe directly, being inferred from modelling and from observations of exoplanetary systems where migration clearly occurred. Even farther out, Uranus and Neptune form more slowly, the disk being less dense at these distances, the orbital periods being longer, collisions being less frequent, these ice giants taking perhaps 10 to 20 million years to reach their current sizes, possibly forming closer to the Sun and migrating outward, possibly being scattered by Jupiter and Saturn's migration, their final positions being where they ended up after the chaotic reshuffling of the early solar system, the exact histories being uncertain, planetary migration being one of the most active areas of research in planetary science. Computer simulations suggesting many possible scenarios, observations of other planetary systems showing diverse outcomes. Our solar system being just one example of how planets can arrange themselves. The disk gradually clears over tens of millions of years, the gas being blown away by the solar wind, the solid material being incorporated into planets or ejected from the system, the collisions becoming less frequent as objects settle into more stable orbits, the chaotic early phase transitioning to the more stable configuration that will persist for billions of years. Though significant events still occur, the most dramatic being the late heavy bombardment, a period of intense impacts that affects the inner planets roughly 4 billion years ago, several 100 million years after the planets initially formed. Time moves forward. You now watch the solar system at 4 billion years ago, the planets having formed, their orbits being mostly stable, but a dramatic event is beginning, caused perhaps by Jupiter and Saturn drifting into orbital resonance with each other, their gravitational interactions with each other becoming synchronized, the resonance amplifying their effects on smaller bodies, asteroids and comets being perturbed from stable orbits, being sent into the inner solar system, raining down on Mercury, Venus, Earth, and Moon, the bombardment lasting hundreds of millions of years but being most intense in a relatively short period between 4.1 and 3.8 billion years ago. The impacts being energetic, creating the large basins visible on the Moon's surface, the Maria being impact craters later filled with lava, the dark patches visible from Earth being the scars of ancient collisions. On Earth, the bombardment might have delivered water, comets from the outer solar system carrying ice that vaporizes on impact, some of the water vapor condensing as the planet cools, forming oceans, though exactly how much water came from comets versus other sources remains debated. Isotopic ratios suggesting Earth's water might have multiple origins, some from local asteroid impacts, some from comets, some perhaps original to Earth's formation. The question being active research, the origin of Earth's oceans being surprisingly uncertain despite their obvious importance to life, the water that covers 71% of our planet having a somewhat mysterious history. The bombardment also affects the early evolution of life, if life existed on Earth this early. The earliest possible evidence for life being from 3.8 billion years ago, right at the end of the heavy bombardment. The impacts might have frustrated early attempts at life, large impacts sterilizing the surface, vaporizing oceans, but also delivering organic molecules from space, creating hydrothermal systems that could nurture early biochemistry, the relationship between bombardment and life being complex, being possibly both obstacle and opportunity, the details being lost to time, the rock record from this period being sparse, metamorphosed by later geological activity, the early history of Earth being difficult to read, being mostly inference rather than direct observation. Eventually, after hundreds of millions of years, the bombardment slows, the orbital perturbations settling down, Jupiter and Saturn moving out of the problematic resonance, the supply of projectiles being depleted, the solar system entering a more stable phase that continues to the present, the impacts still occurring but much less frequently, Earth experiencing perhaps 5 major mass extinction level impacts in the last 500 million years, the KT impact 66 million years ago being the most recent large one, the impact that contributed to dinosaur extinction, but such events being rare now compared to the early bombardment, the solar system having mostly cleaned itself up, most of the debris having been incorporated into planets or ejected, the current configuration being relatively safe, relatively stable, though on cosmic timescales nothing is truly permanent. Orbits drift slowly, chaos being present at very long timescales, the future positions of planets being unpredictable beyond about 100 million years due to the sensitive dependence on initial conditions, the solar system being deterministic but chaotic, like weather but on planetary scales. Remember that cold, dark cloud at the beginning? Now 4.6 billion years later, it has become a star with 8 planets, dozens of moons, countless asteroids and comets, all orbiting in the same direction, all lying nearly in the same plane, the solar system having settled into a configuration that echoes its origin in that rotating disk. The patterns in planetary orbits being fossils of the formation process, evidence that allows us to reconstruct the history to understand how we got here. You now turn your attention to Mercury, the innermost planet, the smallest of the 8 worlds orbiting our Sun, a world of extremes, the planet closest to the solar furnace, experiencing temperatures that swing from intensely hot to deeply cold, having no atmosphere to moderate its climate, being a world of bare rock baked by sunlight and frozen in shadow, a world that reveals what happens when a planet forms so close to its star that everything volatile is stripped away, leaving only the densest material, the core of iron, the remnant of something larger. Mercury is small, barely larger than our Moon, its diameter being 4,880 kilometres compared to Moon's 3,475 kilometres and Earth's 12,742 kilometres, though Mercury being far more massive than Moon despite similar size, Mercury's density being 5.4 grams per cubic centimetre, similar to Earth's 5.5, the high density indicating that Mercury is mostly iron, the planet being roughly 70% metal core, 30% rocky mantle and crust, the proportion of iron being much higher than other rocky planets, Earth being only 32% iron core, the difference being striking, demanding explanation. The mystery of Mercury's composition being one of the interesting puzzles of planetary science, several theories being proposed, but none being definitively proven. Perhaps Mercury formed from particularly iron-rich material in the inner nebula, the region closest to the Sun having different composition than farther out, though models of nebular chemistry don't strongly support this. Perhaps Mercury was once larger, having been struck by a massive object that stripped away most of the rocky mantle, leaving the iron core intact, the collision scenario being similar to how Earth's Moon formed, giant impacts being common in the early solar system, such an impact being plausible, though no direct evidence for it existing, the impact being too long ago to leave detectable traces beyond Mercury's current composition. The surface of Mercury resembles our Moon, being heavily cratered, covered with impact scars from billions of years of bombardment, having no atmosphere to burn up incoming meteorites, no weather to erase craters, no plate tectonics to recycle the surface, the craters remaining as permanent records of the violent history, the oldest regions being saturated with craters, so many craters that new impacts mostly destroy old ones, the landscape being lunar-like but with distinctive features unique to Mercury, particularly the scarps, long cliffs cutting across the surface, the scarps being compression features, wrinkles in the crust from Mercury shrinking as it cooled, the planet's radius having decreased by several kilometres over its history, the cooling and contraction creating stress in the crust cracking and buckling, creating these cliffs that can be hundreds of kilometres long and several kilometres high. The scarps being evidence that Mercury remains geologically active at some level, still cooling, still shrinking, though most internal activity having ceased billions of years ago. The largest feature on Mercury is Caloris Basin, a huge impact crater 1,550 kilometres in diameter. The scar of a collision so energetic that shock waves travelled through the planet, focusing on the opposite side, creating weird chaotic terrain at the antipode, jumbled hills and valleys with no other obvious cause, the basin being surrounded by concentric rings of mountains thrown up by the impact, the crater floor being relatively smooth, probably filled with lava in the aftermath, volcanic activity being triggered by the impact, the heat and pressure of collision causing melting, the molten rock flooding the basin, the surface being marked by this ancient violence, though the event itself being lost to time, having occurred billions of years ago during the heavy bombardment. The exact date being uncertain, but the basin being one of the youngest major features on Mercury, paradoxically being billions of years old, planetary timescales being hard to grasp, young meaning less than 4 billion years old meaning more than 4 billion, the surface being ancient by human standards but young compared to the age of the solar system. Mercury's orbit is unusual, being more elliptical than other planets, the eccentricity being 0.206, compared to Earth's nearly circular 0.017. Mercury's distance from the Sun varying from 46 million kilometres at perihelion to 70 million kilometres at aphelion. The change in distance being substantial, the change in solar heating being significant, the perihelion being 1.5 times closer than aphelion, the Sun appearing 2.3 times larger at closest approach, the intensity of sunlight varying by factor of 5 during Mercury's year, the orbit being shaped by gravitational perturbations from other planets, particularly Venus and Jupiter, Mercury being in the most gravitationally chaotic region of the solar system, being the planet most likely to have orbital instability over billions of years, computer simulations suggesting small probability that Mercury could be ejected from solar system or crash into Venus sometime in next few billion years, the orbit being stable for now but not guaranteed eternal. Mercury rotates slowly, one rotation taking 58.6 Earth days, but orbits quickly, 1 year being just 88 Earth days. The rotation and orbit being locked in 3-2 resonance, 3 rotations equaling 2 orbits. The resonance meaning that the same side faces the Sun every 2 Mercury years, the pattern being, if you stood at a particular location on Mercury and watched the Sun set, the next sunset at that location would occur 2 Mercury years later, the time between sunsets being 176 Earth days. This being the length of Mercury's solar day, the time from noon to noon, being twice as long as Mercury's year, the resonance being unusual, most tidally locked objects having 1-to-1 resonance like Moon showing same face to Earth, but Mercury's high orbital eccentricity allowing the 3-to-2 resonance to be more stable than 1-to-1. The orbital mechanics being subtle, being discovered only when radar observations in 1965 showed rotation period, previously astronomers having assumed 1-to-1 resonance, having been wrong for centuries, Mercury keeping secrets, despite being observed since ancient times. The temperature extremes on Mercury are dramatic, the sunlit side reaching 427 degrees Celsius, hot enough to melt lead, hot enough to vaporize some metals, the heat being intense because of proximity to Sun and lack of atmosphere to redistribute heat, while the night side drops to minus 173 degrees Celsius, among the coldest places in the inner solar system, the temperature swing being 600 degrees Celsius. the most extreme variation in the solar system, the lack of atmosphere meaning no heat transfer from day side to night side. Each hemisphere experiencing its own climate, independent of the other. The contrast being stark, one side being furnace, other side being freezer. The same planet experiencing both extremes. Surprisingly, despite the intense heat on the sunlit surface, ice exists on Mercury, trapped in permanently shadowed craters near the poles, the crater floors never receiving direct sunlight because Mercury's axial tilt is nearly zero, just 0.034 degrees. Essentially no tilt, the poles being defined by rotation axis, craters near poles having floors in permanent shadow. These shadowed regions remaining perpetually below -170 degrees Celsius, cold enough to trap water ice for billions of years, radar observations from Earth detecting bright patches consistent with ice. The Messenger spacecraft confirming the presence of ice through neutron spectroscopy. Organic compounds being found mixed with the ice, perhaps delivered by comets. The discovery being unexpected, ice existing on the hottest planet, the closest to the Sun, the universe being full of such surprises, conditions being more complex than simple models suggest. Though ancient astronomers thought planets wandered randomly across the sky, a view modern orbital mechanics would find charmingly innocent, Mercury's motion is actually highly predictable, following Newton's laws with small corrections from Einstein's general relativity. The perihelion precessing at 43 arc-seconds per century more than Newtonian gravity predicts, the anomalous precession being one of the first tests of general relativity. Einstein calculating the excess precession from curvature of space-time near Sun, the prediction matching observations, providing strong evidence for general relativity. Mercury's orbit being precise test of gravity in the strong field regime, the planet being close enough to the Sun that space-time curvature matters, being the most relativistic planet, being where gravitational theory faces its toughest test in the solar system. Exploring Mercury is difficult, the planet being hard to reach, being deep in the Sun's gravitational well, requiring large velocity change to enter orbit, spacecraft tending to fly past rather than orbit. The first spacecraft visitor being Mariner 10 in 1974-75, making 3 flybys, imaging half the surface, discovering the magnetic field, mapping craters and scarps, revealing Mercury to be moon-like but distinctive, having its own character, its own history. The Messenger spacecraft became the first Mercury orbiter in 2011, spending 4 years mapping the surface, measuring composition, studying the magnetic field, discovering ice in polar craters, revealing unexpected volcanic features, finding evidence of recent volcanism, Mercury being more geologically active than expected, the small planet still having stories to tell, still surprising scientists, the data from Messenger still being analysed years after mission ended, the spacecraft finally running out of propellant in 2015, deliberately crashing into Mercury, creating a new crater, becoming part of the landscape it studied, a tiny artificial feature among the countless natural impacts. The European-Japanese Bepi Colombo mission, launched in 2018, is currently travelling to Mercury, scheduled to arrive in 2025. The spacecraft consisting of 2 orbiters, one studying the surface, one studying the magnetosphere, the mission being designed to understand Mercury's composition, geological history, magnetic field origin, the questions being, why is Mercury so dense? Why does such a small planet have a magnetic field when larger Mars doesn't? What is the nature of the ice in polar craters? How did Mercury evolve? The answers awaiting, the patient work of planetary science continuing, each mission adding pieces to the puzzle, each observation refining our understanding, the picture becoming clearer but never complete, always more questions emerging, the process being asymptotic, approaching complete understanding but never quite arriving. Each answer generating new questions, the scientific process being an infinite game. The goal being not winning, but continuing to play, continuing to learn, continuing to refine our cosmic map, our understanding of the neighbourhood we inhabit. From Earth, Mercury is difficult to observe, always appearing near the Sun in the sky, never straying more than 28 degrees from our star, visible only during twilight, either low on the eastern horizon before sunrise or low on the western horizon after sunset, the observation windows being brief, the planet appearing as bright point of light, slightly yellowish, steady rather than twinkling, its phases being visible through telescopes, Mercury showing crescents and gibbous phases like Venus and Moon, the phases proving it orbits Sun rather than Earth, one of the observations Galileo might have made if his telescope were slightly better. The proof of Copernican heliocentrism being built from such observations, from patient recording of planetary positions and phases, from the realization that Mercury and Venus orbit closer to Sun than Earth does, their maximum elongations being determined by their orbital radii. The best time to observe Mercury from Earth is during greatest elongation, when the planet appears farthest from Sun in the sky, though farthest being only 18 to 28 degrees, depending on where Mercury is in its elliptical orbit, the viewing being better when greatest elongation occurs at perihelion, because Mercury being farther from Earth, appearing smaller but being at higher altitude above horizon, the geometry being complicated, the combination of Mercury's elliptical orbit and Earth's position making some elongations better than others. Ancient astronomers tracking these patterns, creating tables of planetary positions, the predictions being used for astrology and navigation, the practical applications driving early astronomy, the desire to predict celestial events, motivating careful observation and record keeping. Mercury's magnetic field is weak compared to Earth's, about 1% of Earth's field strength, but substantial compared to Venus and Mars, which have essentially no fields. The presence of any field being somewhat mysterious, because Mercury rotates so slowly, taking 59 days per rotation, the slow rotation making magnetic field generation difficult, Earth's field being produced by convection in its liquid iron outer core, the convection being driven by core cooling and by Earth's relatively fast rotation, the rotation organizing fluid motion into columns that generate magnetic field, but Mercury rotating too slowly for this to work efficiently. Yet Mercury has field, the explanation possibly being that Mercury's core is still partially liquid despite the planet being small, the core remaining molten because of sulfur or other elements lowering the melting point of iron, the liquid outer core supporting some convection, some field generation, though the details being uncertain, Mercury's magnetic field being one of the ongoing puzzles. Another question for Bepi Colombo to investigate. The field being offset from Mercury's centre, the magnetic equator being about 500 kilometres north of the geographic equator. The offset suggesting that field generation is concentrated in one hemisphere of the core, perhaps northern hemisphere, having more convection, or the field being more complex than a simple dipole. The magnetosphere being small because of the weak field, extending only about 1 Mercury radius from the surface, compared to Earth's magnetosphere extending many Earth radii, the solar wind compressing Mercury's magnetosphere strongly, sometimes pushing the magnetosphere down to the surface, the planet having little protection from solar wind, the lack of atmosphere meaning charged particles impact surface directly, space weathering darkening rocks, altering surface composition, Mercury's surface being constantly bombarded by solar wind protons, electrons, and solar UV radiation. the environment being harsh, hostile to any hypothetical life, though life being extremely unlikely on Mercury for many reasons. Lack of water, extreme temperatures, lack of atmosphere, lack of organic chemistry, the planet being sterile, being purely geological, being a testament to planetary physics rather than to biology. The surface composition of Mercury has been studied by spectroscopy from orbiters, revealing that surface rocks are low in iron compared to other rocky planets, containing only about 4% iron oxide compared to 10 to 15% for lunar rocks and more for typical terrestrial rocks. The low iron being surprising given that Mercury is mostly iron core, the surface apparently being depleted in iron, perhaps the crust being made of early formed low-density minerals that floated on the magma ocean, leaving iron-rich minerals deeper, or perhaps the iron being locked in the core, the mantle being thin and iron poor, the compositional details being clues to Mercury's formation and evolution, to whether the giant impact hypothesis is correct, whether Mercury lost most of its rocky mantle in a collision, the surface composition being evidence, though interpreting the evidence being difficult, multiple scenarios being possible, the debate continuing, the scientific process being one of constrained speculation, using observations to rule out impossible scenarios, narrowing the field of possible explanations, approaching truth asymptotically. Volcanic features have been identified on Mercury's surface by MESSENGER, showing that Mercury had volcanic activity in its past, possibly continuing until relatively recently in geological terms, perhaps 1 billion years ago, the volcanoes being shield volcanoes similar to Hawaiian volcanoes on Earth, the lava being low viscosity, flowing easily, creating broad, shallow domes rather than steep cones, some volcanic plains being extensive, covering hundreds of thousands of square kilometres. The volcanoes being evidence that Mercury's interior was hot enough to melt rock, hot enough to drive geological activity despite the planet's small size, small planets cooling faster than large planets because they have less volume to hold heat, but more surface area to radiate heat, the surface area to volume ratio being unfavourable for small bodies. Yet Mercury, having been volcanically active for billions of years, the radioactive decay of uranium, thorium and potassium in the mantle providing heat, keeping the interior warm enough for partial melting, for magma to reach surface, the volcanism eventually declining, as radioactive elements decayed, as heat generation decreased, as the planet cooled, Mercury now being mostly geologically dead, the surface being frozen in time, recording the history of the early solar system, being a museum of ancient processes, the oldest surfaces being 4 billion years old, dating from the end of heavy bombardment, being among the most ancient landscapes in the solar system. The study of Mercury teaches us about planet formation, about what happens close to a star, about the diversity of planetary outcomes. Mercury being one data point in a larger picture, one example of a rocky planet, complementing our knowledge of Venus, Earth and Mars, the 4 rocky planets being similar but different, each having unique characteristics, unique history, the differences being clues to formation conditions, to subsequent evolution, to the range of possibilities in planetary systems. Mercury showing the extreme case, the planet most affected by solar proximity, most influenced by the star it orbits, being the planet that tests theories of planetary science, being where simple models fail, where complications become important, being reminder that planets are complex, that each world has its own story, its own contingencies, its own character emerging from the interaction of many factors, initial conditions and random events, and physical laws all combining to create the specific outcome we observe. The story continues, but rest comes easier knowing that Mercury orbits as it has for billions of years, following its elliptical path, rotating in its peculiar 3-2 resonance. The closest planet to our Sun, the fastest orbiter, completing its year in just 88 days, the iron core holding some heat from formation, the cratered surface recording impacts from the solar system's youth, the ice in polar shadows being patient, being ancient, being perhaps billions of years old, older than any ice on Earth, older than Earth's oceans, the water molecules being possibly from the early solar system, being relics of the formation era, being witnesses to everything that followed, frozen in permanent darkness, while just kilometres away the surface bakes in the sun's fierce heat, the contrast being Mercury's character, being extremes, being the world that shows what happens at the edge of habitability, where the sun's warmth becomes too much, where atmospheres cannot survive, where only iron and rock persist, the small planet teaching us about the universe, about physics, about the patient processes that shape worlds, the lessons being valuable, being part of humanity's growing understanding of the cosmic neighbourhood we inhabit, the exploration continuing, the questions multiplying, the knowledge accumulating slowly, each mission adding details, each observation refining theories, the work being never finished, always ongoing, the patient scientific endeavour continuing as it has for centuries, as it will for centuries more. You now shift your gaze outward from Mercury, moving to the second planet from the Sun, Venus, a world that seems so similar to Earth in size and mass, being called Earth's twin, but whose surface conditions are so different, so extreme, that Venus represents perhaps the most dramatic example of how similar starting conditions can lead to radically different outcomes, how planetary evolution can follow divergent paths, how a world that might have been habitable instead became a vision of hell. Though hell being too dramatic a word for our sleep-friendly narrative, let's say instead that Venus became extremely inhospitable, the most hostile surface environment of any rocky planet in our solar system. Venus is almost Earth's size, having a diameter of 12,104 kilometres compared to Earth's 12,742 kilometres. The difference being just 5%, the mass being 82% of Earth's mass, the density being similar, the basic planetary parameters suggesting twin worlds, but the similarities end there, the surface conditions being profoundly different. Venus having thick atmosphere of carbon dioxide at 92 times Earth's atmospheric pressure, the weight of air on Venus being equivalent to being 900 metres deep in Earth's oceans, the crushing pressure being substantial, the atmosphere being almost liquid-like in density, and the temperature being 462 degrees Celsius at the surface. Hot enough to melt lead, hot enough that rocks faintly glow with their own heat, the temperature being nearly uniform across the planet, dayside and nightside, equator and poles, all being equally hot because the thick atmosphere redistributes heat efficiently. The greenhouse effect being runaway, being extreme beyond anything Earth experiences. The atmosphere is mostly carbon dioxide, 96.5%, with nitrogen being 3.5%, the remainder being sulfur dioxide and traces of other gases, the clouds being made of sulfuric acid droplets, concentrated sulfuric acid, 75 to 85% concentration, the clouds forming at 50 to 70 kilometers altitude, where temperature is cool enough for sulfuric acid to condense, the clouds being thick, completely obscuring the surface when viewed from space, Venus appearing as featureless yellowish-white disk when observed with visible light, the cloud tops being smooth, being bright, reflecting 75% of incoming sunlight, Venus being the brightest planet as seen from Earth, being the evening star and morning star that ancient astronomers thought were two different objects, until Greek astronomers realised Venus appeared alternately after sunset or before sunrise, never at midnight, the pattern revealing that Venus orbits Sun closer than Earth does. Beneath the clouds, between 50 kilometres altitude and surface, the atmosphere is clear but hot, temperature increasing steadily with depth, the lower atmosphere being dense enough to move slowly like thick fluid. The weather at surface being calm, winds being less than 1 metre per second. Gentle compared to upper atmosphere, where winds reach 360 kilometres per hour. The clouds racing around the planet in just 4 Earth days. The super-rotation being mysterious, the clouds moving 60 times faster than the planet's surface rotation. The mechanism driving this super-rotation being debated, being one of Venus's atmospheric puzzles. Computer models suggesting various explanations, but no consensus being reached. Venus keeping secrets, despite being observed for millennia. Venus rotates very slowly and backwards, taking 243 Earth days to complete one rotation, rotating retrograde, clockwise as viewed from above the solar system's north pole, opposite to most planets which rotate counterclockwise. The backward rotation being unusual, possibly result of a giant impact that knocked Venus over, or possibly result of tidal forces from the Sun acting on the thick atmosphere, gradually reversing the rotation over billions of years, the exact cause being uncertain, being another Venus mystery. The slow rotation combined with orbital period of 225 Earth days creates unusual solar day length on Venus, one day-night cycle taking 117 Earth days, the Sun rising in west, setting in east, the whole process being leisurely, being slow motion compared to Earth's 24-hour day, though from surface the Sun would never be visible anyway, the thick clouds blocking direct sunlight, the surface being illuminated by diffuse orange glow filtering through clouds. The light being dim, roughly as bright as heavily overcast day on Earth, the colour being orange because clouds scatter blue light, allowing red and orange wavelengths to reach surface. The surface of Venus has been mapped by radar from orbiting spacecraft, radio waves penetrating the clouds and bouncing off surface, the return signals being used to construct topographic maps, the surface being revealed as having continents and lowland plains, 2 highland regions being comparable to Earth's continents, Ishtar Terra in the northern hemisphere being roughly size of Australia, Aphrodite Terra near equator being roughly size of Africa, the highlands being elevated several kilometres above the mean planetary radius, possibly being regions of thicker crust, possibly being ancient terrain, though the absolute ages being uncertain. Venus lacking plate tectonics to recycle crust, lacking erosion from water to wear down mountains, the surface being static compared to Earth, being frozen at whatever state it reached the last time global resurfacing occurred, which might have been 500 million years ago, or might have been more recently, the crater density suggesting relatively young surface, but the interpretation being complicated by Venus's thick atmosphere, which prevents small impactors from reaching surface, only large objects surviving atmospheric entry, the crater counting being difficult to interpret. Volcanic features dominate Venus's landscape, thousands of volcanoes having been identified, ranging from small domes just a few kilometres across to massive shield volcanoes like Mont Mons, which rises 8 kilometres above mean radius. The volcanoes being evidence that Venus has or had active geology, magma reaching surface, lava flows being visible in radar images, some flows extending hundreds of kilometres. The volcanic features being fresh-looking, perhaps indicating recent activity, though recent meaning within last 100 million years. Venus possibly still being volcanically active, though direct observation of eruption being difficult. The thick clouds obscuring surface, the Soviet Venera landers detecting possible lightning, which might be associated with volcanic eruptions. The question of current activity being unresolved, being target for future missions. Speaking of Soviet Venera missions, the exploration of Venus's surface has been heroic effort, the extreme conditions making landing and survival difficult. The first successful landing being Venera 7 in 1970, transmitting data for 23 minutes from the surface before succumbing to heat and pressure, subsequent missions being better protected. Venera 9 and 10 in 1975, sending first images from surface, black and white photographs showing flat rocky plains, layered rocks, pieces of apparently volcanic origin, the horizon being visible in the images, the sky being bright orange, the landscape being alien but recognizable, being rocky desert of sorts, though desert far hotter than any on Earth, being pressure cooker environment, being place where spacecraft electronics fail rapidly despite heavy insulation. Venera 13 and 14 in 1982 sent colour images showing orange-lit landscape, flat rocks, soil between rocks, the colour being confirmed, the surface being illuminated by orange light filtered through clouds, the landers carrying drills to sample surface material, measuring composition, finding basaltic rocks similar to Earth's oceanic crust, the results being consistent with volcanic origin, the rocks being similar to what forms from lava flows, Venus appearing to have basaltic crust like Earth's ocean floor, but lacking plate tectonics to recycle it, lacking water to alter it, the crust being primary volcanic rock, being relatively pristine despite its age. The record for longest survival on Venus's surface being held by Venera 13, which functioned for 127 minutes over 2 hours, sending images and data before failing. The achievement being remarkable given the conditions, the engineering being impressive, the Soviet scientists and engineers solving enormous technical challenges, creating spacecraft that could survive long enough to tell us about this extreme world, the data being valuable, being our only direct samples of Venus's surface environment, subsequent missions being orbiters rather than landers, focusing on radar mapping and atmospheric studies rather than surface exploration, the Magellan mission in the 1990s creating detailed radar maps of entire planet, revealing geological complexity, showing evidence of volcanism, tectonics different from Earth's plate tectonics, perhaps having episodic global resurfacing events where entire crust melts and reforms, the evidence being suggestive but not conclusive, the debate about Venus's geological history being ongoing. The great question about Venus is whether it was ever habitable, whether it had liquid water oceans in its past, whether it was Earth-like before becoming the hothouse it is today, the answer mattering for understanding habitable zones around stars, for predicting which exoplanets might support life, for knowing whether Venus's fate could befall Earth. The current scientific thinking is that Venus probably had water early in its history, the water coming from volcanic outgassing or cometary impacts, as it did on Earth, but that Venus lost its water through runaway greenhouse effect, the mechanism being positive feedback loop. Early Venus receives more sunlight than Earth because Venus is closer to Sun, the extra heat causing more water to evaporate, water vapour being greenhouse gas, trapping more heat, causing more evaporation, the cycle continuing until all water evaporates into the atmosphere, the water vapour rising to upper atmosphere where ultraviolet light from Sun breaks H2O molecules apart, hydrogen escaping to space because it's light, oxygen either escaping or reacting with surface rocks, the result being that Venus loses its water permanently, the hydrogen being gone, irretrievable, and with water gone the carbon cycle breaks down, carbon dioxide accumulating in atmosphere instead of being locked in carbonate rocks, as happens on Earth, the thick CO2 atmosphere creating greenhouse effect that maintains high temperature, the state being stable, being self-sustaining, Venus being locked into this hot state, unable to cool down without intervention. The question is, when this happened, how long Venus had oceans, whether life could have emerged before the runaway greenhouse occurred, the answers being unknown, being speculative, some scientists suggesting Venus might have had oceans for billions of years before losing them a billion years ago, the sun gradually brightening over time, eventually triggering the runaway greenhouse, others suggesting Venus lost water very early, perhaps within the first 100 million years, never having a long habitable period, the evidence being scarce, being difficult to find, the current surface showing no signs of ancient oceans, no sedimentary rocks, no carbonates, though such evidence might have been erased by volcanic resurfacing, by the extreme heat recycling the surface. The question being open, being target for future exploration, Venus life science missions being proposed, looking for chemical evidence of past oceans, looking for isotopic ratios in rocks that would reveal water history. An even more speculative question is whether life could exist in Venus's clouds. The idea being that while surface is far too hot, the cloud layer at 50 to 60 kilometers altitude has Earth-like temperature and pressure, approximately 25 degrees Celsius and 1 atmosphere, the clouds being acidic, but some Earth life tolerates acidic environments. The clouds containing water droplets along with sulfuric acid, microbes potentially surviving in the droplets, drifting in the atmosphere, the hypothesis being intriguing but lacking strong evidence. Recent detection of phosphine gas in Venus's atmosphere being potentially interesting because phosphine on Earth is produced primarily by anaerobic life, but the phosphine detection being controversial. Some scientists questioning whether it's really there, others questioning whether it necessarily indicates life rather than unknown atmospheric chemistry. The debate being active, being fascinating, Venus possibly harbouring life in its clouds. Being wild speculation but not completely impossible, the patient scientific investigation being needed to resolve the question. Remember Mercury's extreme temperature swings and lack of atmosphere. Venus shows the opposite extreme, atmosphere being thick enough to maintain uniform temperature, being heavy enough to crush spacecraft, being chemical environment utterly hostile to life as we know it, yet Venus being Earth's twin in size, the divergent evolution being cautionary tale, being reminder that small differences in initial conditions can lead to dramatically different outcomes. You now turn your attention to Earth, the third planet from the Sun, the world you know best, the pale blue dot that is humanity's home, the only place in the universe where we know life exists, though we suspect it might exist elsewhere and actively search for it. Earth remaining unique so far, being the baseline against which we compare other worlds, being the standard for habitability, being precious beyond measure, despite or perhaps because of its cosmic insignificance. As Carl Sagan reflected, when Voyager 1 photographed Earth from 6 billion kilometers away, our planet appearing as tiny pale blue speck against the vastness of space, barely 1 pixel in size, all of human history occurring on that mote of dust suspended in a sunbeam. Earth orbits Sun at average distance of 150 million kilometers, 1 astronomical unit by definition, taking 365.25 days to complete 1 orbit, the extra 0.25 days accumulating over 4 years to create leap days. Our calendar compensating for the fact that Earth's year is not exactly 365 days. The orbital period being determined by Earth's distance and the Sun's mass, Kepler's third law relating orbital period to orbital radius. The mathematics being precise, being beautiful, Earth's orbit being nearly circular, eccentricity being just 0.017. the distance from Sun varying only 5% between perihelion and aphelion, the variation being small enough that seasons are caused by Earth's axial tilt rather than by distance changes, the 23.5 degree tilt, meaning that during northern summer, the North Pole points towards Sun, northern hemisphere receiving more direct sunlight. During northern winter, the North Pole points away, northern hemisphere receiving sunlight at glancing angle, the seasons being reversed in southern hemisphere, being result of geometry rather than distance. Earth's surface is 71% ocean, salt water covering most of the planet, the ocean being interconnected, all oceans being parts of one world ocean, Pacific being largest portion, Atlantic being second, Indian being third, the ocean being essential to Earth's climate, absorbing solar heat, redistributing it via currents, Gulf Stream warming Europe, Kuroshio, current warming Japan, the ocean moderating temperature extremes, making Earth more habitable than it would be otherwise, the ocean also being essential to life, being where life originated roughly 3.8 billion years ago, being where most biodiversity exists, coral reefs and deep sea vents hosting ecosystems, whales migrating across ocean basins, tiny plankton forming the base of food chains, producing much of Earth's oxygen despite being microscopic, the ocean being Earth's life support system, being precious, being threatened by human activity. But that's too sombre for our sleep narrative. Let's focus on the ocean's beauty, its rhythms, the tides rising and falling twice daily, the waves rolling endlessly toward shores, the patient motion of water-shaping coastlines. The land surfaces, 29% of Earth's area, are divided into 7 continents, though the number being somewhat arbitrary depending on how you count, North and South America sometimes being counted as one continent, Europe and Asia being connected as Eurasia but counted separately for historical reasons, Antarctica being ice-covered, Australia being smallest continent or largest island depending on definition, the land being dynamic unlike other rocky planets, Earth having plate tectonics, the crust being divided into plates that move slowly, centimetres per year, the movement being driven by convection in Earth's mantle, hot rock rising beneath mid-ocean ridges, cooling and sinking at subduction zones, the plates carrying continents, occasionally colliding and creating mountain ranges, Himalayas being formed by India, crashing into Asia, the collision continuing, Mount Everest rising millimetres per year, tectonic activity being what makes Earth geologically alive, what recycles crust, what causes earthquakes and volcanoes, what drives the carbon cycle that regulates climate over millions of years, plate tectonics being unique among rocky planets in our solar system, being gift of Earth's size and heat, smaller planets like Mars cooling too quickly, losing internal heat, becoming geologically dead, larger planets possibly having too much heat, too much volcanism, Earth being just right, being in the sweet spot. Earth's atmosphere is unusual, 78% nitrogen, 21% oxygen, the oxygen being produced by photosynthetic life, by plants and algae and cyanobacteria splitting water molecules and releasing O2, the oxygen accumulating in atmosphere over billions of years, transforming atmosphere from early reducing atmosphere to current oxidizing one. The Great Oxidation Event roughly 2.4 billion years ago being one of Earth's major transitions, oxygen being poison to early anaerobic life, the rise of oxygen causing mass extinction of organisms that couldn't tolerate it, but also enabling complex life, enabling aerobic respiration which extracts more energy from food than anaerobic metabolism, the oxygen being both curse and blessing, being transformative, being sign of life. Any planet with significant atmospheric oxygen being worth investigating for biological activity. Oxygen being chemically reactive, requiring constant replenishment, its persistence in Earth's atmosphere being evidence of ongoing photosynthesis of active biosphere. Earth's magnetic field is generated by convection in the liquid iron outer core, the core being maintained in liquid state by Earth's internal heat, the heat coming from residual heat of formation from radioactive decay of uranium, thorium, and potassium in mantle and crust, from gravitational energy released as denser iron sinks towards centre and lighter material rises, the heat being enough to keep outer core molten, the core being roughly the temperature of Sun's surface, 5,000 to 6,000 Kelvin, though pressure being extreme, keeping inner core solid despite high temperature, the outer core fluid iron being electrically conductive, the convection of conductive fluid generating magnetic field through dynamo effect, the field extending tens of thousands of kilometers into space, creating magnetosphere that deflects solar wind, protecting atmosphere from being stripped away, protecting surface from charged particles, the magnetic field being essential to Earth's habitability, Mars having lost its magnetic field early in its history, subsequently losing most of its atmosphere to solar wind, becoming cold, dry desert. Earth avoiding this fate because core remains liquid, because Earth is large enough to retain heat, the size being important, being what saves Earth from Mars's fate. Earth's moon is unusual, being very large relative to planet it orbits, Moon's diameter being 27% of Earth's diameter, the mass ratio being 1 to 81, most moons of other planets being much smaller relative to their planets, the large size being result of Moon's formation through giant impact, a Mars-sized protoplanet called Theia hitting early Earth roughly 4.5 billion years ago, the collision ejecting material that coalesced into Moon, the impact being energetic enough to vaporize rock, to create magma ocean covering Earth's surface, the Moon forming from debris in orbit, the formation scenario being supported by several lines of evidence, including oxygen isotopes in lunar rocks being identical to Earth's, indicating common origin, the Moon being made of Earth's mantle, being sister world rather than captured asteroid, the Moon's influence on Earth being substantial, the tides being most obvious effect, Moon's gravity pulling on Earth's oceans, creating two tidal bulges, high tides occurring when location rotates through bulge, low tides when between bulges, the tidal friction gradually slowing Earth's rotation, making days longer, 4 billion years ago. Earth's day being only 6 hours, the slowing being gradual but persistent. Eventually Earth will become tidally locked to Moon as Moon is to Earth, though that taking billions of years far in the future. The Moon also stabilizes Earth's axial tilt, preventing large variations that would cause climate chaos, the 23.5 degree tilt being maintained within a few degrees over millions of years because of Moon's gravitational influence. Without Moon, the tilt varying by tens of degrees over tens of thousands of years, the seasons being extreme and unpredictable. Mars experiencing this, having small moons that don't stabilize tilt, Mars's axial tilt varying from 15 to 35 degrees, possibly more, the climate being chaotic, the Moon being gift to Earth's climate stability, being one reason Earth's climate has been stable enough for complex life to evolve. Humans walked on the Moon between 1969 and 1972. 12 Apollo astronauts experiencing lunar gravity, collecting 382 kilograms of rock samples, deploying seismometers that revealed Moon's internal structure, discovering that Moon has small iron core, thick mantle, thin crust thicker on far side than near side, the rocks being ancient, 3 to 4.5 billion years old, being from early solar system, being preserved because Moon lacks atmosphere, lacks plate tectonics, lacks erosion, the surface being museum of early solar system, being scientifically valuable, the samples being studied for decades, still yielding new insights, the Apollo program being humanity's first visit to another world, being achievement worth remembering, being source of pride despite being motivated by political competition, the science and engineering triumphs being real regardless of motivation. You now shift your gaze to Mars, the fourth planet, the red planet that has fascinated humanity for centuries, being bright rust-coloured object visible to naked eye, being called war god in many cultures because of its blood-red colour, the colour being from iron oxide on surface, from rust, Mars being rusty planet, being oxidised world, the iron in surface rocks having reacted with oxygen in past, when Mars had thicker atmosphere, the rust being ancient, being evidence of different climate long ago. Mars is roughly half Earth's size, 6,792 kilometres in diameter, the mass being 11% of Earth's mass, the surface gravity being 38% of Earth's, making Mars much easier to launch from than Earth, one reason Mars is considered for future colonisation, getting to orbit from Mars requiring much less energy than from Earth. The atmosphere is thin, mostly carbon dioxide at 0.6% of Earth's pressure, the air being too thin to breathe, too thin to protect from radiation, too thin to retain much heat. Surface temperature averaging minus 60 degrees Celsius, ranging from minus 140 at winter poles to plus 20 at summer equator. The temperature range being large because thin atmosphere doesn't moderate climate, Mars having extreme seasons similar to Earth's, but more severe because of thin atmosphere and larger orbital eccentricity. The surface of Mars is divided into two hemispheres, northern hemisphere being low smooth plains, probably ancient ocean floor, southern hemisphere being heavily cratered highlands, the dichotomy being one of Mars's major features, the cause being debated, possibly giant impact early in Mars's history, possibly internal processes, the question remaining open. The surface is marked by ancient river valleys, deltas, lake beds, the features being clear evidence that liquid water flowed on Mars's surface billions of years ago, the rivers having carved channels hundreds of kilometres long, the lakes having existed for thousands or millions of years, leaving sedimentary deposits, the water eventually freezing or evaporating as Mars lost its atmosphere, as climate changed. The question being what happened, why Mars changed from relatively warm wet world to cold dry desert. The answer being that Mars lost its magnetic field early in its history, probably within first 500 million years, the core cooling quickly because Mars is small, solidifying perhaps, or at least convection stopping, the dynamo shutting down, without magnetic field, the solar wind stripping away atmosphere, ions being accelerated by solar wind, electric field escaping to space, the process being gradual, taking hundreds of millions of years, but relentless, eventually reducing atmosphere to current thin state. The remaining atmosphere being what solar wind cannot reach, being protected by Mars's topography, by the fact that solar wind interacts with upper atmosphere rather than surface, but the protection being imperfect, Mars continuing to lose atmosphere today, modern spacecraft measuring current loss rate, confirming that solar wind is culprit, that Mars's small size doomed its atmosphere, the planet being unable to maintain magnetic field long enough to protect atmosphere for billions of years. Olympus Mons, largest volcano in solar system, rises 22 kilometers above Mars's mean surface level, the height being 2.5 times Mount Everest. The volcano being shield volcano like Hawaiian volcanoes, gentle slopes averaging 5 degrees, the caldera at summit being 80 kilometers across, containing multiple collapse craters, the size being possible because of low gravity and lack of plate tectonics. On Earth, volcanoes cannot grow so large because crust moves, carrying volcanoes away from hotspots, creating volcanic chains like Hawaiian Islands. But on Mars, crust is static, volcanism occurring in same location for billions of years, allowing Olympus Mons to grow to enormous size, the volcano being relatively young, showing lava flows that might be only millions of years old, Mars possibly still being volcanically active, though no eruptions having been observed. Valles Marineris is canyon system extending 4,000 kilometers along Mars's equator, being 7 kilometers deep and up to 200 kilometers wide, dwarfing Earth's Grand Canyon, which is 446 kilometers long, 1.6 kilometers deep, 29 kilometers wide at widest point. Valles Marineris being tectonic feature rather than water-carved canyon, being result of crust fracturing as Tharsis volcanic region bulged upward, the stress creating parallel faults, the faults collapsing to form canyons, though some widening possibly from water erosion from catastrophic floods when subsurface ice melted. The full history being complex, being studied by orbital cameras revealing layers in canyon walls, sediments suggesting past water. The canyon being treasure trove of geological information, being target for future missions. Mars has polar ice caps, both water ice and carbon dioxide ice, the North Polar Cap being mostly water ice, with thin seasonal CO2 frost layer. The South Polar Cap being mostly water ice with thick permanent CO2 ice layer, the caps growing and shrinking with seasons as CO2 freezes and sublimes. The seasonal cycle being dramatic, roughly 25% of Mars's atmosphere freezing out at winter pole, creating low pressure that drives winds from summer to winter hemisphere, the atmospheric pressure varying by 25% over the Martian year. The dynamic atmosphere being driven by CO2 phase changes, being unique to Mars, being consequence of having atmosphere near CO2's sublimation temperature, the caps being scientifically interesting, containing layered deposits that record climate history. The layers being like tree rings, recording periods of dust deposition and ice accumulation, revealing that Mars's climate varies on 50,000 to 100,000 year timescales as obliquity changes, as orbit eccentricity changes. The climate being chaotic at long timescales but predictable at short timescales, the layers being readable, record of recent climate, recent meaning last million years. Mars exploration has been extensive, more missions sent to Mars than to any other planet except Earth, the Soviet, American, European, Indian, and Chinese space agencies all having sent successful missions. The orbiters mapping surface in detail, discovering features, monitoring weather, measuring subsurface ice with ground-penetrating radar. The landers and rovers studying surface composition, drilling into rocks, analysing chemistry, searching for organic molecules, for signs of past water, for conditions that might have supported life. The rovers being mobile laboratories, Spirit and Opportunity operating 2004 to 2010 and 2004 to 2018 respectively, far exceeding their 90-day design lifetimes, exploring several kilometres each, discovering minerals that form in water, finding evidence of past liquid water, Curiosity landing in 2012, still operating, climbing slopes of Mount Sharp, finding organic molecules in ancient lake sediments, confirming that early Mars had conditions suitable for life. Perseverance landing in 2021, collecting samples for future return mission, deploying Ingenuity helicopter, which made first powered flights on another planet, demonstrating aerial exploration capability, each mission advancing our understanding, answering questions but raising new ones, the exploration continuing. The big question remains, was there life on Mars? the ancient warm, wet period being potentially habitable, liquid water existing for perhaps hundreds of millions to a billion years, organic molecules being delivered by comets or produced by atmospheric chemistry, energy sources including sunlight, chemical reactions at hydrothermal vents, the ingredients for life being present. The question being whether life actually emerged, whether Mars had biology, whether fossils or chemical signatures remain in ancient rocks, the search being ongoing, Perseverance collecting samples from ancient lakebed, the samples being returned to Earth by future mission in 2030s hopefully. The samples being analysed in laboratories using techniques impossible to deploy on Mars, the answer possibly being within reach, being perhaps just years away, though also possible that no conclusive evidence will be found, that Mars's early history being too altered by later processes, the rocks being too weathered, the question remaining frustratingly open despite our best efforts. Between Mars and Jupiter, you notice the asteroid belt, a region of space roughly 2 to 4 astronomical units from Sun containing millions of rocky objects. The asteroids being leftover material from solar system formation, being planetesimals that never formed planet. Jupiter's gravity preventing accretion in this region, stirring orbits, increasing collision velocities, causing planetesimals to fragment rather than merge. The belt being not dense despite movie depictions, the average spacing between asteroids being millions of kilometers, spacecraft traversing belts without special maneuvers, the asteroids being sparse, being scattered across enormous volume, the total mass being less than Moon's mass, roughly 4% of Moon, all asteroids combined being insufficient to make respectable planet, the material being spread too thin, being prevented from gathering by Jupiter's influence. The largest asteroid is Ceres, diameter 950 kilometers, being massive enough to be spherical, being classified as dwarf planet, having ice mantle beneath rocky crust, possibly having subsurface ocean. Dawn spacecraft orbiting Ceres from 2015 to 2018, discovering bright spots that are salt deposits, evidence of water reaching surface and evaporating, leaving salts behind. Ceres being active in some sense, having cryovolcanism perhaps, water ice behaving like lava at Ceres's cold temperature. The small world being more interesting than expected, being another ocean world possibly, joining Europa, Enceladus, and several other moons as places where liquid water might exist. Asteroids are valuable scientifically because they preserve primitive material from solar system formation, the oldest meteorites being 4.567 billion years old, dating from earliest solar system, containing calcium-aluminum inclusions that formed when solar nebula first condensed, the inclusions being first solid material in solar system, being time capsules, every meteorite being sample of early solar system available for laboratory study on Earth, the meteorites being free sample return missions, nature delivering asteroid material to our doorstep, though doorstep being whole planet, the infall being random, meteorites being found where they fall or where ice sheets concentrate them, Antarctica being good place to find meteorites, dark rocks being visible on white ice movement concentrating meteorites at certain locations. You now arrive at Jupiter, the king of planets, the largest world in our solar system, the gas giant that dominates the outer solar system, being 318 Earth masses, being 2.5 times more massive than all other planets combined, being almost massive enough to be star, needing to be 80 times more massive to ignite hydrogen fusion, Jupiter being failed star in some sense, though stellar physicists would object to that characterization, Jupiter being successful planet, being magnificent gas giant, being exactly what it should be given the mass available in outer solar nebula. Jupiter orbits Sun at 5.2 astronomical units, taking 11.9 Earth years per orbit, the planet being visible from Earth as bright steady point, brighter than most stars, second only to Venus in brightness among planets. Jupiter being impressive even to naked eye, through telescope being stunning, the cloud bands being visible, zones and belts alternating, bright zones being high altitude clouds of ammonia ice, dark belts being lower, warmer regions where clouds are deeper, the banding being created by differential rotation, Jupiter's equator rotating slightly faster than poles, winds blowing in alternating directions at different latitudes, creating stable pattern of bands that has persisted for centuries, probably for much longer, though telescopic observations only covering last 400 years. The Great Red Spot is Jupiter's most famous feature, being anticyclonic storm, high pressure system, larger than Earth, measuring roughly 16,000 kilometers by 10,000 kilometers, currently though the size varying over decades. Historical observations showing Great Red Spot was larger in 1800s, being perhaps 40,000 kilometers across, the storm shrinking slowly, possibly weakening, possibly dissipating someday, though it's been observed continuously since 1830, possibly existing much longer. Early observers reporting similar feature centuries earlier, the storm being possibly 350 years old or more, being extraordinarily persistent, Earth's hurricanes lasting days to weeks, Jupiter's Great Red Spot lasting centuries, the atmospheric physics being different because Jupiter lacks surface, lacking friction that dissipates Earth's storms, Jupiter's storm being maintained by drawing energy from atmospheric flow, from the shear between different latitude bands, the storm being self-sustaining as long as atmospheric dynamics continue. Jupiter has no solid surface, being mostly hydrogen and helium. The atmospheric gases gradually becoming denser with depth, transitioning from gas to liquid without distinct boundary. The pressure and temperature increasing with depth, hydrogen eventually becoming liquid metallic hydrogen at pressures of millions of atmospheres, thousands of kilometers deep. The metallic hydrogen being electrically conductive, the convection of metallic hydrogen generating Jupiter's strong magnetic field, the magnetosphere extending millions of kilometers, being largest structure in solar system aside from Sun's heliosphere. The magnetic field trapping charged particles, creating radiation belts similar to Earth's Van Allen belts, but much more intense, the radiation being hazardous to spacecraft, requiring shielding and planning of trajectories to minimize exposure. Jupiter has 95 known moons as of last count, though new small ones being discovered regularly, the count increasing as telescopes improve. The four largest being Galilean moons, discovered by Galileo in 1610, being Io, Europa, Ganymede, and Callisto, all being substantial worlds, being planets in their own right if they orbited Sun instead of Jupiter, each having unique character, unique geology, being diverse despite all orbiting same planet. Io is innermost Galilean moon, being slightly larger than our moon, being most volcanically active body in solar system, having hundreds of active volcanoes, eruptions occurring continuously, lava flows visible in infrared images, volcanic plumes shooting hundreds of kilometers high, the volcanism being driven by tidal heating, Jupiter's gravity pulling on Io, Europa and Ganymede pulling on Io, the gravitational forces varying because Io's orbit is slightly elliptical, the varying gravity flexing Io's interior, friction generating heat, the heat being enormous, Io's interior being molten, the surface being constantly resurfaced by lava, Io having no impact, craters, because surface is too young, volcanic activity erasing craters faster than they form, Io being yellow and orange and red, the colours being sulphur and sulphur compounds from volcanic gases, the moon being exotic, being alien, being demonstration of what tidal forces can do. Europa is next, being slightly smaller than our moon, being covered with ice, the surface being smoothest in solar system, having very few craters, the ice being young, the surface showing cracks and ridges where ice has fractured and refrozen, the patterns suggesting liquid water beneath the ice. The ice shell being perhaps 10 to 30 kilometers thick, beneath it being global ocean possibly 100 kilometers deep, containing twice the water in Earth's oceans, the ocean being maintained liquid by tidal heating from Jupiter, the tides flexing Europa's interior, generating heat through friction, the heat being enough to prevent freezing, despite Europa being in outer solar system far from sun's warmth, the ocean possibly having hydrothermal vents on seafloor where water interacts with rocky interior, the vents potentially providing chemical energy that could support life, analogous to deep sea vents on Earth which host ecosystems independent of sunlight. Europa being prime target for astrobiology, being place where extraterrestrial life might exist. NASA planning Europa Clipper mission to arrive in 2030s to orbit Jupiter and make multiple flybys of Europa, studying the ice shell, measuring ocean depth, analysing surface composition, searching for plumes of water vapour being ejected from cracks. The plumes potentially allowing sampling of ocean without needing to drill through kilometres of ice. The mission being exciting, being humanity's best near-term chance of finding life beyond Earth. Ganymede is largest moon in solar system, being larger than Mercury, being 5,268 kilometers in diameter, being substantial world, having iron core, rocky mantle, ice shell, being differentiated like terrestrial planets, being only moon known to have its own magnetic field, the field being generated by dynamo in liquid iron core, Ganymede being geologically complex, having old dark cratered terrain and younger bright grooved terrain, the grooves being tectonic features where ice crust has stretched and fractured, cryovolcanism having resurfaced parts of the moon, Ganymede possibly having subsurface ocean like Europa, radar sounding suggesting liquid water layer between ice layers, though less certain than Europa's ocean, Ganymede being less tidally heated, being farther from Jupiter, the tidal forces being weaker. Callisto is outermost Galilean moon, being heavily cratered, having most ancient surface of the fore, being geologically dead or nearly so, lacking the tidal heating that drives activity on Io and Europa. Callisto being mixture of ice and rock, probably not fully differentiated, being cold and static, though also possibly having subsurface ocean, being less certain than Europa or Ganymede. Magnetic field measurements suggesting conducting layer at depth, possibly liquid salt water, though the ocean being deep if it exists, being separated from rocky interior by ice layers, making it less interesting for astrobiology than Europa, because no contact between water and rock, no chemical energy source, Callisto being stable, quiet, ancient, its surface recording 4 billion years of impacts, being museum of bombardment history. 4 billion years. The 4 Galilean moons showcase planetary diversity, all orbiting the same planet, all exposed to similar radiation and temperature, yet having different characteristics, different histories, different levels of activity. The differences being determined by distance from Jupiter, by orbital resonances creating different amounts of tidal heating, by size affecting heat retention and differentiation, each world being result of specific circumstances, specific initial conditions, and subsequent evolution. The moons being laboratories for comparative planetology, teaching us about how worlds work, what drives geological activity, what conditions might support life. The knowledge being applicable to moons of other giant planets, to exomoons of exoplanets. The lessons from Jupiter's moons informing our understanding of planetary systems throughout the universe. The story continues forward, but rest comes easier, knowing Jupiter's great red spot still swirls, the Galilean moons still orbit in their resonant pattern, Io's volcanoes still erupt, Europa's ice still covers its secret ocean, the giant planet holding, caught in the outer solar system, being gravitational anchor, being dominant presence, spinning rapidly once every 10 hours, its clouds racing, its magnetic field sweeping through space, the patient dance continuing as it has for 4.6 billion years. You now travel farther from the Sun, moving beyond Jupiter to Saturn, the sixth planet, the ringed jewel of our solar system, perhaps the most visually stunning world when viewed through a telescope, the rings being so distinctive, so elegant, that Saturn seems almost unreal, almost too perfectly designed, though the rings are entirely natural, being physical consequences of gravity and orbital mechanics, their beauty being accident of physics rather than cosmic artistry, though the effect being artistic nonetheless, Saturn being favourite target of amateur astronomers, being planet that inspires wonder even in experienced observers who have seen it hundreds of times, the rings never losing their capacity to amaze. Saturn is second largest planet, being 95 Earth masses, 9.5 Earth diameters, being similar to Jupiter in composition, mostly hydrogen and helium, having no solid surface, the gas transitioning to liquid with depth, becoming liquid metallic hydrogen in deep interior, the same basic structure as Jupiter, but less massive. Saturn's lower density being 0.69 grams per cubic centimetre, less than water, meaning Saturn would float if you could find an ocean large enough, though finding such an ocean being impossible, being thought experiment rather than practical proposal. The low density indicating that Saturn has proportionally more hydrogen and less heavy elements than Jupiter, the difference being result of formation conditions and subsequent evolution, Saturn forming farther from Sun where disk was less dense, capturing less mass before solar wind dispersed remaining gas. Saturn orbits at 9.5 astronomical units, taking 29.5 Earth years to complete one orbit, the planet being visible from Earth as bright yellowish point, not as bright as Jupiter, but still prominent. Saturn being easily visible to naked eye, known since ancient times, the rings being discovered by Galileo in 1610, though his telescope being too weak to resolve them clearly. Galileo seeing handles on either side of planet, not understanding what they were, the rings being properly identified by Christian Huygens in 1655 with better telescope, though even Huygens thinking rings were single, solid disk, the true nature being multiple, separate ringlets, being discovered later by improved observations. The rings being made of countless individual particles, each orbiting Saturn independently. The ring system being particle swarm rather than solid structure. The rings are made almost entirely of water ice, 99% water ice with 1% rock, the particles ranging from dust-sized to house-sized, most being centimetre to metre scale, the rings being remarkably thin relative to their width, most being less than 10 metres thick vertically, but extending 280,000 kilometres from planet centre. The thinness being consequence of collisions between particles, any particle with vertical velocity eventually colliding with other particles, losing vertical component of motion, the system settling into thin disk, like sediment settling to bottom of pond. The analogy being imperfect, but capturing the basic physics. The rings being dynamically thin, being self-flattening structure. The ring system is divided into several main rings, designated by letters in order of discovery rather than position. D ring being innermost, then C, B, A, F, G, E, from inner to outer. The B ring being brightest, being most opaque. A ring being next brightest, Cassini division being gap between A and B rings. Being visible from Earth with good telescope, the gap being maintained by gravitational resonance with Mimas moon, particles in Cassini. Division orbiting twice for every orbit of Mimas, the resonance destabilizing orbits, removing particles, creating gap, similar mechanisms creating other gaps and structures in rings, shepherd moons confining F ring, gravitational interactions sculpting ring structure. The rings are surprisingly young, being perhaps only 100 million years old, possibly being created by small moon that ventured inside Saturn's Roche limit, the distance within which tidal forces exceed moon's self-gravity, the moon being torn apart, debris forming rings, or perhaps being created by collision between two moons, the fragments being spread into rings, the age being determined by brightness and purity of ice. Older rings would accumulate more dust, becoming darker. Saturn's rings being bright and clean, suggesting young age, though the question being debated, some models suggesting rings could be ancient, but being continuously renewed, old material falling onto planet, being replaced by new material from small moons being disrupted, the dynamics being complex, the age being uncertain, being active area of research. Saturn has 146 known moons as of recent count, though number changing as new small moons are discovered, Titan being by far the largest, being 5,150 kilometers diameter, being larger than Mercury, being second largest moon in solar system after Ganymede. Titan being unique among moons in having thick atmosphere, the atmosphere being mostly nitrogen like Earth's, but being 1.5 times thicker, surface pressure being 1.5 atmospheres, the atmosphere being opaque, hiding surface in visible light, Titan appearing as featureless orange sphere in visible images, the orange colour being from organic haze in upper atmosphere, complex hydrocarbons being created by ultraviolet light breaking apart methane, the fragments recombining into complex molecules, creating thick smog. Titan's surface was revealed by Cassini spacecraft using radar and infrared instruments that can penetrate the haze, the surface showing lakes and rivers, but not water, the temperature being minus 179 degrees Celsius, water being solid as rock, the lakes being liquid methane and ethane. Titan having hydrocarbon cycle, analogous to Earth's water cycle, methane evaporating from lakes, forming clouds, raining back down, carving river channels, forming pools and lakes, mostly at polar regions, the largest lake, Kraken Mare, being larger than Caspian Sea on Earth, being substantial body of liquid methane ethane, the surface being alien yet familiar, having landscapes shaped by similar processes to Earth but using different materials, erosion, creating familiar features, rivers meandering, lakes having shorelines, the universality of physics, creating convergent evolution of landscapes. The Huygens probe landed on Titan in January 2005, descending by parachute through the thick atmosphere, photographing the surface during descent, showing what appeared to be river networks draining into flat areas, touching down on what mission controllers described as sand, covered by thin crust, the surface being soft but having harder substrate beneath, the images showing rounded rocks that were probably ice pebbles, the landscape being dim, illuminated by diffuse orange light filtering through atmosphere, Huygens surviving for 90 minutes on surface before battery exhausted, the temperature being cold enough to freeze methane, making surface conditions bizarrely alien yet physically comprehensible, Titan being place where understanding Earth's processes helps understand alien world, where same physics applies but boundary conditions being different, producing different outcomes. Titan possibly has subsurface ocean of liquid water beneath ice crust, beneath surface, the ocean being detected by measuring how Titan's shape changes due to Saturn's tides, solid body being rigid, but body with liquid interior being flexible, deforming more in response to tides. Cassini measurements showing tidal deformation consistent with liquid water layer, perhaps 100 kilometers beneath surface. The ocean being separate from surface methane lakes. Being hidden water ocean beneath ice and rock, the ocean possibly being salty, possibly being habitable to Earth-like life, though isolated from surface, having no sunlight, no obvious energy source, the habitability being speculative, Titan being interesting for astrobiology because of both surface organic chemistry and possible subsurface ocean, being place where two different types of chemistry might occur, surface being too cold for water-based life, but possibly supporting exotic life using liquid methane as solvent, subsurface ocean possibly supporting conventional water-based life, Titan being double opportunity, being two worlds in one. Titan Enceladus is much smaller moon, only 500 kilometers diameter, being 20 times smaller than Titan, yet being extraordinarily interesting, being one of most scientifically valuable worlds in outer solar system, Cassini, discovering that Enceladus has geysers of water vapour erupting from fractures near South Pole, the tiger stripes being warm compared to rest of moon, being source of plumes that shoot water hundreds of kilometres into space, the water mostly falling back to surface as snow, some escaping to form Saturn's faint E-ring, Cassini flying through the plumes, analysing their composition, detecting water vapour, ice particles, organic molecules, hydrogen gas, salt, the chemistry suggesting that plumes originate from subsurface ocean, that ocean is in contact with rocky core, that chemical reactions at water-rock interface are occurring, possibly providing chemical energy that could support life, Enceladus being prime astrobiology target along with Europa and Titan, being place where all ingredients for life might exist, liquid water, organic molecules, energy sources, the small moon being possibly habitable despite being far from sun, being heated by tidal forces from Saturn. The Cassini mission, arriving at Saturn in 2004, operated for 13 years, making detailed observations of Saturn, the rings and moons, the spacecraft making 294 orbits of Saturn, 162 close flybys of Titan, 23 flybys of Enceladus, discovering new moons, new ring features, monitoring Saturn's seasons and storms, observing hexagonal polar vortex at North Pole, the six-sided jet stream being strange geometric feature, being consequence of wave dynamics in rotating atmosphere, the Cassini mission ending in September 2017 with grand finale, the spacecraft making 22 dives between Saturn and innermost ring, sampling ring particles, measuring gravity field, studying Saturn's deep interior, then deliberately diving into Saturn's atmosphere to avoid contaminating potentially habitable moons. Cassini burning up, becoming part of Saturn, the mission being extraordinarily successful, revolutionizing our understanding of Saturn's system, providing data that scientists will analyze for decades. Remember Jupiter's dynamic atmosphere and volcanic moon. Saturn shows similar but different patterns, gas giant with storms and bands, but less dramatic, having moons with subsurface oceans like Jupiter, but also having Titan with thick atmosphere and surface lakes, each giant planet having its own character while following similar themes. The variations teaching us about planetary science, about how same physical laws produce different outcomes depending on specific conditions. You now travel even farther outward, reaching Uranus, the seventh planet, the sideways world, the planet that is literally rolling around the Sun, having axial tilt of 97.8 degrees, meaning its rotation axis lies nearly in its orbital plane, the poles alternately pointing at Sun during its 84-year orbit, each hemisphere experiencing 42 years of continuous daylight, followed by 42 years of continuous darkness, the extreme seasons being unlike anything in inner solar system. The cause of tilt being mysterious, probably giant impact early in planet's history, something massive hitting Uranus, knocking it over, or perhaps series of smaller impacts, the exact history being unknown, being lost to time, Uranus keeping this secret among others. Uranus is ice giant rather than gas giant, being 15 Earth masses, 4 Earth diameters, being smaller than Jupiter and Saturn, having different internal structure, the interior being mostly ices, meaning water, methane, and ammonia under high pressure and temperature. These being compressed liquids and exotic high pressure phases rather than familiar ice, hydrogen and helium being present but not dominant, Uranus and Neptune representing different planet type compared to Jupiter and Saturn. The distinction being important for understanding planet formation, for classifying exoplanets, ice giants being different category. The atmosphere of Uranus is mostly hydrogen and helium with few % methane, the methane absorbing red light, making planet appear blue-green, the colour being distinctive, being paler than Neptune's deeper blue. Uranus appearing calm in visible images, having very few clouds, very few features, the atmosphere seeming almost featureless, though infrared observations revealing more activity, revealing clouds and storms that are invisible in visible light, Uranus being more active than it appears, though still much less active than Jupiter or Saturn or Neptune, the low activity possibly being related to internal heat, Uranus radiating less heat than Neptune despite similar size. Uranus possibly having lost primordial heat, or having different composition affecting heat retention, the question being debated. Uranus was discovered by William Herschel in 1781. Being first planet discovered with telescope, ancient peoples knowing Mercury through Saturn by naked eye observation, Uranus being too faint to notice without telescope. Herschel initially thinking he discovered comet, the object appearing as small disk rather than point, but orbit being calculated to be nearly circular, being planetary rather than cometary, the discovery doubling the known size of solar system, being major event in astronomy, Uranus being named after Greek god of sky, father of Cronus, Saturn, continuing mythological naming tradition. Uranus has been visited only once, by Voyager 2 in January 1986, the spacecraft making close flyby, photographing planets and moons, discovering new moons and rings, measuring magnetic field, finding that field is tilted 59 degrees from rotation axis and offset from planet center, the unusual field configuration possibly being related to tilt, possibly being typical of ice giants. But we don't know because Neptune's field being similar, possibly ice giant magnetic fields being generated differently than gas giant fields, in slushy ice mantle rather than metallic hydrogen core, the limited data from single flyby being insufficient to fully understand Uranus, the planet deserving dedicated orbiter mission, being priority for planetary science but being expensive and distant. Mission requiring decades to reach Uranus, being long-term project. Uranus has 28 known moons, most being named after Shakespeare characters rather than mythological figures, the naming being charming quirk, Miranda being most interesting moon, being small, only 470 kilometers diameter, but having bizarre patchwork surface, having several distinctly different terrains stitched together, having enormous cliff, Verona Rupees, being 20 kilometers high, highest cliff in solar system, Miranda looking like it was broken apart and randomly reassembled, the appearance possibly being result of differentiation interrupted by tidal heating, the interior starting to separate into layers, then freezing, preserving partially differentiated state, or possibly being result of large impact that fractured moon, fragments falling back together, the interpretation being uncertain, Miranda being mystery, being moon that seems to tell story of violence and disruption, but the story being hard to read. You now reach Neptune, the eighth and final planet, the farthest major planet, the blue world at the edge of the planetary system, being 30 astronomical units from Sun, taking 165 Earth years to complete one orbit, Neptune having completed only one orbit since its discovery in 1846, being very distant, very cold, being place where Sun appears as bright star rather than disk, solar heating being 900 times weaker than at Earth, yet Neptune being surprisingly active, having strongest winds in solar system despite its distance from Sun, winds reaching 2,100 kilometers per hour, far faster than any winds on Jupiter or Saturn or Earth. The wind speeds being difficult to explain, Neptune radiating 2.6 times more energy than it receives from Sun, the internal heat driving weather, though source of heat being unclear, being either residual heat from formation or ongoing gravitational contraction or some other process, Neptune keeping this secret. Neptune is similar to Uranus in size and composition, being 17 Earth masses, being ice giant, having similar blue colour from atmospheric methane, but Neptune's blue being deeper, more vivid, the difference possibly being from different haze layers or different trace chemicals in atmosphere, the exact cause being uncertain. Neptune's atmosphere is dynamic, having large storms, the Great Dark Spot being photographed by Voyager 2 in 1989, being anticyclonic storm similar to Jupiter's Great Red Spot, though smaller and less persistent, the Great Dark Spot having disappeared when Hubble Space Telescope observed Neptune in 1994, new dark spots appearing and disappearing over years, Neptune's storms being transient, unlike Jupiter's long-lived features, the atmospheric dynamics being different, possibly related to internal heat, to planet's rapid rotation, to atmospheric composition, the differences teaching us about planetary atmospheres, about how different conditions create different behaviours. Neptune was discovered mathematically before being observed, astronomers noticing that Uranus's orbit deviated from predictions, the deviations being explainable by gravitational pull of unseen planet, Urbain Le Verrier in France, and John Couch Adams in England independently calculating where the planet should be, Le Verrier sending predictions to Johann Galle at Berlin Observatory. Galle finding Neptune on first night of searching in September 1846, being within 1 degree of predicted position, the discovery being triumph of celestial mechanics, of Newtonian gravity, proving that mathematical physics could predict existence of unknown worlds, the discovery being major validation of scientific method. Neptune has 16 known moons, Triton being by far the largest, being 2,700 kilometers diameter, being comparable to Europa and Pluto, Triton being unusual among large moons because it orbits retrograde, going opposite to Neptune's rotation, the retrograde orbit indicating that Triton was captured, originally being Kuiper belt object that Neptune's gravity captured, the capture being possible because of 3 body interactions, Triton encountering Neptune moon system, being slowed by gravitational interaction, falling into orbit around Neptune, the original moon being ejected or colliding with Triton, the details being speculative, captured moons being rare for large moons, Triton being special. Triton's surface is young, having few craters, the surface being nitrogen ice with darker streaks, having cantaloupe terrain showing strange texture of intersecting ridges, having ice volcanoes or cryovolcanoes erupting. Nitrogen geysers, Voyager 2 observing dark plumes rising 8 kilometers above surface, being carried 150 kilometers downwind by thin atmosphere, the geysers possibly being driven by seasonal heating, transparent nitrogen ice acting like greenhouse, subsurface nitrogen being warmed above freezing point, exploding through surface, the geysers being evidence of geological activity on small moon far from sun, the activity being surprising, being consequence of Triton's captured nature, tidal heating during orbit circularization having heated interior, remnant heat still driving cryovolcanism millions of years later. Triton is slowly spiraling inward, tidal forces from Neptune causing orbital decay. Eventually Triton will cross Neptune's Roche limit, being torn apart by tides, the debris forming ring system around Neptune, the process taking hundreds of millions of years, being distant future, but being inevitable consequence of physics, captured moons being temporary on cosmic timescales, their orbits being unstable, gravity being patient executioner. Beyond Neptune's orbit you find the Kuiper Belt, region of icy objects extending from Neptune at 30 astronomical units to roughly 50 astronomical units, being disk of small icy bodies similar to asteroid belt but farther out, colder, containing more mass, being reservoir of short period comets, objects occasionally being perturbed into inner solar system by gravitational interactions, becoming comets as they approach Sun, ice sublimating creating tails, the Kuiper Belt being discovered in 1990s, though predicted earlier, being populated by thousands of known objects, probably millions existing, most being small, diameter less than 100 kilometers, some being larger, some being dwarf planets. Pluto, discovered in 1930, being considered ninth planet until 2006, when International Astronomical Union defined planet. More precisely, Pluto being reclassified as dwarf planet, being large enough to be rounded by its own gravity but not massive enough to clear its orbital zone of other objects. The reclassification being controversial among public but being appropriate scientifically, Pluto being one of many similar objects in Kuiper Belt, being prototype of new class of objects rather than being lone oddball planet, the reclassification reflecting improved understanding of solar system architecture. Pluto is 2,377 kilometers diameter, being about 2/3 moon size, having 5 moons, largest being Charon, which is half Pluto's diameter, the Pluto-Charon system being almost binary planet, the two being tidally locked to each other, both showing same face to each other constantly, the pair orbiting their common centre of mass, which lies outside Pluto's surface, technically making them binary system rather than planet-moon system, though distinction being somewhat semantic, the system being whatever we call it. Pluto was visited by New Horizons spacecraft in July 2015, the flyby revealing Pluto to be geologically active despite being small and cold, the surface showing mountains of water ice, plains of nitrogen ice, glaciers flowing, possible ice volcanoes, Tombor Regio, heart-shaped feature, having smooth plains called Sputnik Planitia being actively resurfaced, nitrogen ice convecting like lava lamp, solid nitrogen being warmed from below, becoming less dense, rising, cooling at surface, becoming denser, sinking, creating convection cells visible as polygon patterns, each cell being 10 to 40 kilometers across, the surface being only millions of years old, possibly younger. Pluto being geologically active through unknown mechanism, possibly radiogenic heating from rocky core, possibly tidal heating from interaction with Charon, possibly heat from differentiation process, the exact energy source being debated. The New Horizons images showing landscape of startling beauty, mountains silhouetted against Pluto's hazy atmosphere, blue hazes created by sunlight interacting with methane and nitrogen, the atmosphere being thin but present, Pluto having weather, frost forming and sublimating seasonally, the distant world being complex, being interesting, being worthy of exploration, the New Horizons data proving that small icy worlds far from Sun can be geologically active, can have interesting history, can be worth visiting. At the very edge of the solar system, far beyond Kuiper Belt, lies the Oort cloud, theoretical sphere of icy objects never directly observed but inferred from long-period comets that enter inner solar system on trajectories suggesting they come from distant reservoir, the Oort cloud being spherical rather than disc-shaped, extending from perhaps 2,000 astronomical units to 200,000 astronomical units, almost 2 light-years being halfway to nearest star, the Oort cloud objects being weakly bound to Sun, being easily perturbed by passing stars, by galactic tides, the perturbations sending some objects into inner solar system as comets. The Oort cloud being estimated to contain trillions of objects based on observed comet rate, total mass being perhaps several Earth masses distributed across enormous volume, the density being incredibly low, average spacing being tens of millions of kilometers. Comets are icy bodies from Kuiper Belt or Oort cloud that approach Sun, ice sublimating as they warm, creating coma of gas and dust surrounding nucleus, solar radiation ionizing gas, solar wind pushing ions, creating ion tail pointing away from Sun, dust particles reflecting sunlight, creating dust tail curving along comet's orbit, comets developing tails as they approach Sun, tails fading as they recede, the show being temporary, lasting months, comets being visible to naked eye occasionally, bright comets like Halley or Hale-Bopp being memorable events, ancient peoples regarding comets as omens, modern science understanding them as chunks of ice and rock, as pristine material from solar system formation, as time capsules containing volatiles that never experienced high temperatures, the comets being scientifically valuable, missions having visited several comets, collecting samples from Wild 2, landing on 67P/Churyumov-Gerasimenko, studying composition, learning about early solar system chemistry. Studying time moves forward billions of years into future, the solar system evolving, the Sun gradually changing, the current stable state being temporary on cosmic timescales, stars being mortal, having life cycles, the Sun currently being middle-aged, having burned through roughly half its hydrogen fuel, having perhaps 5 billion years remaining as main sequence star, the future being predictable from stellar evolution models, from observing other stars at different life stages, the Sun's fate being written in physics, being deterministic. The Sun brightens slowly, gradually, 1% per 100 million years, the brightening being consequence of helium accumulating in core, the helium being denser than hydrogen, core contracting slightly, heating up, fusion rate increasing, the Sun producing more energy, radiating more light, the trend being slow but inexorable. In roughly 1 billion years, Earth's oceans starting to boil away, water vapour creating runaway greenhouse effect, Earth becoming Venus-like, life being extinguished, the habitable period on Earth being limited, though 1 billion years being vast time on human scales, being 200 times longer than complex life has existed so far, being essentially infinite from our perspective, but being finite from cosmic perspective. In roughly 5 billion years, the Sun exhausts core hydrogen, fusion stopping at centre, core contracting, heating, shell of hydrogen around core beginning to fuse, the shell fusion releasing more energy than core fusion did, the extra energy puffing up Sun's outer layers, the Sun expanding into red giant, swelling to perhaps 1 astronomical unit radius, possibly swallowing Mercury, definitely swallowing Venus, possibly swallowing Earth, models disagreeing about Earth's fate, some saying Earth will be engulfed, others saying Earth will survive, but will spiral inward due to tidal forces and drag from Sun's extended atmosphere, being scorched regardless, any remnant being molten rock, Earth's story ending here, the planet that hosted life for billions of years becoming sterile cinder or being vaporized completely. Mars might briefly become habitable as Sun's warmth increases, ice melting, atmosphere thickening, but the warmth coming from dying star, the habitable period being brief, measured in millions of years at most. The outer planets possibly having their moons temporarily warmed, Europa's ice melting, Titan's methane evaporating, but again briefly, the changes being transient, the Sun's red giant phase, lasting only hundreds of millions of years, being short chapter in Sun's long life. Eventually, helium accumulates in core, igniting through helium flash, sudden onset of helium fusion, the violence being brief, helium burning stabilizing, the Sun burning helium into carbon and oxygen for perhaps 100 million years, becoming hotter but smaller than red giant phase, then outer layers being puffed off as planetary nebula, beautiful glowing clouds of gas illuminated by hot core, the nebula expanding, dispersing into interstellar space, enriching galaxy with heavy elements, the same process that created the carbon and oxygen and iron in our bodies. We being made of star stuff, as Carl Sagan said, being literally made of ashes from previous generations of stars, the Sun eventually contributing its processed elements to future generations, the cycle continuing. The core remains as white dwarf, incredibly dense object, size of Earth but mass of Sun, no longer fusing, just slowly cooling, radiating stored heat, taking trillions of years to cool completely, becoming black dwarf eventually, cold, dark ember. Any remaining planets orbiting this stellar corpse, the solar system becoming graveyard, the Sun having shone for roughly 10 billion years total, having illuminated 8 planets, dozens of moons, countless smaller bodies, having made life possible on at least one world, possibly others if we discover life on Mars or Europa or Enceladus, the Sun's legacy being preserved in whatever records survive, in whatever intelligence evolved here, in whatever we accomplish before the warmth ends. It is late now, very late, the hour being past midnight. You stand in a quiet mission control room at Jet Propulsion Laboratory in Pasadena, California. The facility being mostly dark, daytime shifts having ended, only skeleton night crew remaining, monitoring spacecraft scattered across solar system and beyond, the patient work of space exploration continuing around the clock, machines exploring on our behalf, sending data across millions or billions of kilometers, the signals taking minutes or hours to arrive, being received by massive radio dishes, being decoded and processed and displayed on screens in this darkened room. The control room smells faintly of coffee, the night shift staple, someone having brewed fresh pot an hour ago, the aroma mixing with the scent of electronics, of warm computer equipment, of the recycled air that flows through the building's ventilation system. The room is quiet except for the soft hum of computers, the occasional click of keyboard, as engineer logs observation, the distant sound of air conditioning maintaining precise temperature. The atmosphere being calm, professional, patient, the work being mostly monitoring, watching telemetry, verifying that spacecraft systems remain healthy, that solar panels generate power, that heaters maintain temperature, that antennas point correctly, that scientific instruments collect data, the routine tasks being essential, being unglamorous foundation of exploration. One screen shows Voyager 1's status, the spacecraft being 24 billion kilometers away, signal taking 22 hours round trip. Voyager being in interstellar space, having crossed heliopause in 2012, being first human-made object to leave solar system, though leave being ambiguous since gravitationally. Voyager remains bound to Sun, but Voyager has entered the region where interstellar medium dominates, where solar wind gives way to particles from nearby stars, Voyager still transmitting data, the 23-watt signal being incredibly weak after travelling such distance, being barely detectable above background noise, requiring sensitive receivers and signal processing, but the data being received showing conditions at edge of Sun's influence, revealing the boundary between solar system and galaxy, Voyager's instruments being designed for planetary flybys, being not optimal for interstellar studies, but continuing to function, continuing to teach us about our cosmic neighbourhood. Another screen shows Mars rover status, Perseverance having parked for Martian night, solar panels folded, instruments sleeping except for atmospheric sensors that continue measuring pressure and temperature. The rover being in Jezero crater, exploring ancient river delta, collecting samples for eventual return to Earth. The mission being years from completion, being patient long-term project, Perseverance having sibling back on Earth, engineering model used for testing, technicians wearing clean room suits, rehearsing commands before uploading. The care being essential because correcting mistakes on Mars being difficult when commands take 20 minutes round trip, every action being planned, simulated, verified before execution. A third screen shows Juno's orbit around Jupiter, the spacecraft being in highly elliptical polar orbit, swooping close to Jupiter's cloud tops every 53 days, measuring gravity field, magnetic field, microwave emissions from deep atmosphere, photographing aurora, studying Great Red Spot, Juno's mission being extended because spacecraft remains healthy, because science questions remain unanswered, because we haven't exhausted Jupiter's capacity to teach us about planet formation, about atmospheric dynamics, about magnetospheres, about how gas giants work. The listener is drifting now, consciousness fading, sleep approaching, the story of solar system being complete, the journey having travelled from cloud of dust 4.6 billion years ago to present day, from formation to current state, from single star to 8 planets, dozens of moons, countless smaller bodies, all held together by Sun's gravity, all orbiting in same direction, in same plane, echoes of ancient rotation, memories of swirling disk, the patient accumulation of dust into worlds, the collisions and migrations and evolutions creating the specific configuration we observe, the contingencies and physics combining to produce our cosmic home. Remember that cold, dark cloud at the beginning? Now it's become the solar system, you know, Mercury baking close to Sun, Venus shrouded in thick clouds, Earth spinning with its oceans and life, Mars waiting in cold silence, Jupiter dominating with its great red spot still swirling after centuries, Saturn's rings still orbiting, Uranus rolling on its side, Neptune's winds still howling despite distance from Sun's warmth, Pluto and Kuiper belt objects drifting in the cold outer darkness, comets occasionally diving inward, all held together by Sun's gravity, all illuminated by Sun's steady light, the same light for 4.6 billion years, the same warmth making planets visible, making Earth habitable, making solar system home. Planets visible somewhere above you tonight, if you're on Earth's night side, planets continue their ancient paths. Jupiter is bright and steady in the sky, Saturn visible if you know where to look, the planets being there as they've been for millennia, as they will be for billions of years more, patient in their orbits, indifferent to human observation, beautiful regardless of whether anyone watches. The cosmic clockwork continuing, precise and eternal on human timescales, though temporary on cosmic timescales, the Sun and planets having perhaps 5 billion years remaining before major changes occur. The timescale being so vast that 5 billion years is essentially forever, being comfortable infinity. You are on one of those worlds, this pale blue dot, under the same sun that illuminates all the others, part of this system, this neighbourhood, this corner of galaxy, citizen of solar system, though spending life on one planet, connected to the rest through gravity and sunlight and shared history, the atoms in your body being recycled, stardust being ancient as solar system, being remnants of stellar deaths, being assembled into you temporarily, eventually returning to cosmic cycle, your consciousness being brief pattern in eternal material, experiencing the universe observing itself, the cosmos contemplating its own structure through your awareness. The strange loop of existence being miraculous, regardless of whether it has purpose, the fact of consciousness being wonder enough. Rest now, under these stars, in this system, part of this cosmic dance. These stars. The sun will rise tomorrow, the planets will continue orbiting, the patient work of exploration will continue, spacecraft sending data, scientists analysing observations, slowly building understanding piece by piece, generation by generation, the knowledge accumulating, the mystery shrinking, but never disappearing, there always being more to learn, deeper questions to ask, farther places to visit, the frontier being infinite, the horizon being eternal, the work being never finished but always worthwhile. Sleep well, fellow traveller, under the same sun, in the same solar system, home.